Hi guys, subscribe, like, and comment. Okay, so I would like to talk about extern C. So imagine we have a file called main.c, or I don't know, maybe f.c. Okay, it will implement some function. It really does not matter what it does, but it matters that this is pure C code. Okay, so we will compile it, but not exactly. We will do -c. Okay, so we got this object file. Okay, so in theory this is compiled code of this one, but we did not linkage it. Okay, so okay. Now let's imagine that we have actual C++ program. Okay, so it is actual program, and imagine we need this function f. Okay, how to do it? Okay, okay, so yeah, let's just do it by this one. So we will do g++ main C++. Okay, it says it is not declared in the scope. Okay, so this is compile. Okay, because if I will do -c, we can see it is compile. So how to change this? Okay, obviously we need to do something. So first step is to do it via include, but we don't have actually include file. So we can say extern void f. Okay, but if we do it like this, we actually can compile. Okay, but not link. Okay, so in order to link, let's try main.f.o, which is object file we compiled, remember, with this function, but we compiled with C compiler. Okay, and now we are using not GCC but G++. Okay, so actually to make it work, we will change a little bit. We will say extern C. Okay, yeah, basically that's all. So now we'll do G++ main CPP. Okay, without this we actually don't have a reference, so we also need to linkage this f.o file. Okay, now we can see that it works. So yeah, basically that's it. So this is the main purpose of this extern C. Okay, so actually we can use our C libraries. Okay, that's cool and that's perfect. Okay, yeah, so basically that's the idea of this keyword. Okay, now let's talk about friend. So basically we have some class. Okay, class struct doesn't matter, and it has some private field, private int e. Okay, so now if we create this class c.e equal to, okay, so this, as you know, will be some error. Okay, is private. Okay, within this context. Okay, but imagine we want to keep it private. Okay, because it is private, but we want to make main be able to use private stuff of our class. Okay, so what do? We just do friend int main, like this. Okay, you see, nice, it's working. So basically that is the idea behind this friend keyword. So yeah, basically you define which functions are able to access private fields of this object of this class. Okay, nice. Okay, now I want to talk about goto. Okay, I mean, we all know we don't use it, but anyway, let's just briefly talk about it. So imagine we have int e equals 2, then int g equals e plus 1, int k equals j plus y. Okay, seems great, right? But what if I will say that we will use some goto? Okay, so how to use goto? Okay, so for example, we have 1, 2, 3, and 4. So this is also a working code, right? Okay, no, it's not working. I guess because of this. Yeah. Okay, now it's working. And what about gotos? Okay, so we have 3 labels. Okay, 1, 2, 3. Okay, that's good. Okay, I don't know, let's imagine that we will have some goto statement. Okay, let's say go to, I don't know, 2. And what will happen? Jump to label 2 from here, node crosses crosses initialization of int I. Okay, no problem. Just to be sure if it will be here, it will not have an error, right? So actually, it is erroring because here we initialize 2, and if here we are going directly to here, so this one is not actually invoking, and this is maybe the case that we don't have this I. Let's check. Okay. Yeah. So, and yeah, here is the problem between this, for example, this goto. So if this goto skips, so basically we cannot have creating any variables between goto and its label. Okay, so this is the first caveat. I don't know. Okay, second one. Imagine from here we will go to, I don't know, 1. Okay, what actually will happen? And it is interesting one. Actually, let me put it here. Okay, so what is the cool stuff is going on here? Okay, I will say that we actually will create a class just to, so you will understand what actually is going on. So I will just name C, and it will have some custom destructors that will print to see out some, I don't know. Okay. Include string. Yeah, and actually we will create C, and here also C, J. Yep, and what is going on here? Of course, it is infinite loop, because here we go to 1, and after that we will eventually go to 1 again and again and again. Okay, but what I want to say is that here we create a variable, but here we are jumping to here, but the main idea of goto is that we will destroy these variables. And by saying that, I'm not joking, okay? I did this one to make sure it is how it is. Okay, so we will just check now. Okay. Yeah. Let's remove this not working code right now. Yeah, and also this one. Okay, it's still not working. In function C is okay. Yeah, that is because I did not specify this public. Okay. Yep, so here we see that destruction, and yeah, that is what is the problem with go to? Okay, so when we go to, it's distracting. Yeah, actually that's all. Yeah, that's all. That's really all. Because so yeah, when we go from here to here, it is unwinding stack, right? So it's calling the structures for this stuff. This can be a tricky one. So yeah, basically that is what it is. And actually, when we use switch, when we use break or continue, those three are basically go-to statements. Yes, I mean case, okay. So yeah, this is the go-to statements. I mean, it is working like go-to statements, so be careful with that, especially with switch. That's why some prefer to not use it at all. Yeah. Yeah, but the idea is the same here, here, and here. Yeah, that's all I think about go-to. Okay, now let's talk about some different topic. Let's talk about inline functions. So imagine we have some function, doesn't matter what it does. We have int main, of course, and this main calls this function, okay? So we will compile this code. We will get some a.out. Okay, let's move it to a.out1. Okay. Now we will use this inline, I guess, like this. And yeah. And now we will move it to. Okay, so we have two versions. Okay. Let's just diff out. Okay, so they differ. Okay. And let's just check sizes. Okay. Okay, but that's not really accurate. Okay, so if I will go to a.out1, or I will actually use a.1. Okay, it doesn't actually show. Okay, here I have two lines exactly as here. The last line is like this. Okay, and here. Okay, so here we see it's bigger, right? Yeah, it's bigger. And here. It's equal. Okay, guys, so I think that is not a good example. Okay, so I need to create something more valid. Okay, I'll give me a sec. Okay, so as we saw, a.out is bigger. It uses inline and it is actually bigger. And what is the idea for inline? That it is inserting the function, basically the function, the actual function. It inserts it into the actual call place. So this is good for performance, but as you can imagine, it is bad for size, right? Because it inserts it. So in order to properly test it, I would say we would have something like rand. Okay, I want to use rand string. So something we have to insert. Okay, and now I will just insert a lot of these lines. Okay. Okay, so I insert a lot of these lines. Okay, so now I will remove all out, and I will G++ the inline version. Inline. Okay. And I will go to the main, remove inline. Actually, wait, please. I would say let's do it this way. Yeah, so I actually increased the size of the whole function. So in theory, if we insert the function body instead of function call, it will grow the size of the program. Yeah, I think that's logic. G++ main cpp. Okay, now change inline to simple function call. Okay, and now we will get special size of these files and we will make our conclusion. I think we can just check with VC. Yeah, and I think this is actual count of bytes. Oh, nice. It is. Quickly check VC. Yes, it's the same bytes, but okay. Maybe by default it's also inlining. Can it be the case? Okay, guys. So in practice, I don't see anything. So here we can see assembly code at the right, and I think you cannot properly see it because of the screen font size, but just as size you can see the size of it, and here basically it is call square int. But if I will paste inline here, it actually does not change. So I will not explore this any further. If you have some insights about inline, let me know in the comments, please. Okay guys, so the next one is pretty easy, I think, and obvious. It's mutable, so imagine we have class, it has private int I, so yeah, you cannot change it, or you can. Okay, 1 second guys. Okay guys, so let's continue where we finished. Yeah, so we are talking about mutable stuff, right? So what does it mean mutable? So let's say I created some class, it has some let's say I, okay, but what is the problem? Okay, so I can change I, right? But what if I will have const? Okay, uninitialized. Okay, that's good. Okay, so the problem I have here is that I need, if I want const, I need to have some value, let's say 1. Okay, now it compiles. Okay, great. But what if I will do cc.I equals to, okay, this is prohibited because, okay, it's private. But let's make it public, just to show that this is not the case. Okay. Read only objects. So what is the problem? because we have const here. So what if we do mutable? Mutable. I think it will change the situation slightly. Yep. So as you see, it compiles, and basically that's all. I don't think we can have mutable function. Yes, so mutable is only for variables, so we are good to go. Namespace, I think it's easy. Yeah, I think that's easy. We don't need actually to do it. Yeah, well, actually, let's just state one thing that if we are gonna have a template class, so this class will be template. I don't know, it will have some variable, and it will also have some function. And what is the problem here? I don't know. No, I think there will be no problem. I think the problem will be... Okay, let's make this... doesn't matter. Let's have another class D, which will be from C. Okay, and we'll have some function or not. Yeah, let's just do it. Also, this will not work because we cannot create actually D. Yeah, because class name. Wait. Yeah, it's strange. Okay, let's do int. Okay, now it's... But what if we don't know? Then we say also... we say the same stuff. And we say C. Okay, it does not work. Because we need to do it here. Int. Okay, now it works. Okay, and I have one question. Yeah, can we do like this? DE. Yep, we cannot do it. Wait, it's private. Okay, let's do quickly public. Oh, yeah, nice. So yeah, it's inaccessible. You will say why it's inaccessible. And I will say because C is templated, and in order to do it, we will have to do something like this, and I'm not sure which is one. Yeah, so probably we will do something like this. Yeah. This is cave of what is going on here. Okay, I think I got it. So what we actually do is this. No? Why not? Okay, maybe here. D is not a class. Okay. One last chance. Okay. Okay, guys. So if we have derived class from template class, it is easy to do it like this. So we make function, and to access this parent class item, we do it like this, we say class names, then we pass this. Basically, we copy this one, double semicolon, and variable of this class, and this one works. But it doesn't work from here. So from here it's easier to call like this. Yeah. So I mean, yeah, that's all about what have we discussed. Yeah, namespace. So basically this is the namespace. Okay, I think we got it. And yeah, okay, I think let's finish a video now. I will upload this video and I will go actually sleep. Okay, yeah, so thanks guys. Please like button, subscribe, comment, yeah, and propose, I don't know, some theme you want, or I don't know, yeah, just please comment. Okay, thanks, bye.